All right, we're going to evaluate, let's evaluate this definite integral. Now, if you look at this, you might think, what the heck, how am I going to approach this? And I think that would make sense to have that point of view, or to think that reaction. But there's a trick here. Let's check out the integrand, which is x to the third power plus x to the fourth tan x. Notice we're going from negative pi over to pi over 4 to pi over 4. And what's going to happen is we're going to have symmetry here. This is an odd function. If I replace x by negative x, then let's see what we get. For negative x to the third power, that's negative x to the third power. For negative x to the fourth, that's just positive x to the fourth. And then tangent is an odd function. I don't know if there's an odd identity, it's an odd function. The way you can remember that is the tangent x is symmetric around the origin, but essentially this all is equal to negative f of x. So f is an odd function. And I'm doing a bunch of explanation here, but we're going to have a really quick answer. It's going to come together very quickly. Here is okay, I don't know what the graph of this looks like, but it could look something like this. It could look, by the way, if you put x as 0, all that's 0. And so it could sort of look like the tangent graph, but it could be something like this, but it's an odd function. And there's symmetry around the origin. And the result is that the area between the curve and the x-axis to the right there is the same as the area to the left. All right, I sort of fell apart on that sentence there, but these two regions that I have are exactly the same area. Now, when I integrate, what does that lead to? It leads to the answer is 0, because integration is equal to the area above the x-axis minus the area below. And because of that symmetry, the two cancel each other out. And it's very important, I mean, it was necessary that we're going from negative pi over 4 to pi over 4 when it's an odd function to get that cancellation. So anyway, the answer is 0. And if you once you see this an odd function, then if you go from negative pi over 4 to pi over 4, then you get 0. So I could even extend this video to, if f is odd, then the integral from negative a to a of f of x dx is equal to 0. That's the principle that I'm using here. Any questions?
Professor, can you explain the odd function thing again?
Well, odd functions are that if you have f of negative x equals negative f of x, that's the definition of odd function. And so you have to plug in negative x. So the harder one, or the one you have to remember, is the tangent x is an odd function. The tangent negative x is equal to negative tan x. But odd functions have symmetry around the origin, which means, you know, if you have one point AB, then negative AB is another point, and those points will mirror through the origin.
So you wouldn't use substitution for this?
No, they
okay.
snuck it in there. Snuck it in there. Yeah, we're not going to try to integrate this by anything except we lucked out. It's an odd function. I can integrate x to the third power. Well, that would, anyway, the whole thing's going to be 0, whichever method I did. But okay. So let's end the video.